Good afternoon, all. Thanks, Mike, for taking your time to speak with us. It's been a wonderful experience in CDOIQ Symposium. We have learned a lot about data quality, data governance, and the biggest thing is data readiness for AI and AI itself, right? So pretty exciting. We in Royal Cyber as a professional services specializing in data, we are very excited, and we are discussing with Yeedu and Mayank, who is the Chief Product Officer for Yeedu, about partnerships where we can work together. So, Yeedu, if you can introduce yourself and tell us a little bit about your organization.
Sure, thanks, Saurav. So, my name is Mayank. I work in the product organization for Yeedu. And Yeedu is a next generation data processing platform. Essentially, what we've seen in the market is that the number one cost item in the enterprise cloud bill for most enterprises is the cost related to data and analytics. And it's also the fastest growing line item. So that's the problem that we set out to solve. How can we run the data workloads more efficiently in a much more performant manner? And that's how the genesis of Yeedu came about. We've looked at some of the optimizations on what can be done to run the workloads a little faster. At the core of Yeedu is a Spark engine, is a re-architected Spark engine, where we swapped out the default execution engine of Spark and built our own turbo engine that accelerates the execution of workloads by about 4 to 10x. So faster execution would mean that the workloads run for lesser time, and therefore the cloud resources that are used are that much lesser, and therefore the cost incurred on running these workloads goes down. That's one level of optimization. The other thing that we did is something called smart scheduling. We looked at how the workloads run on CPU, and when we looked at the utilization of compute, we found that for most of the workloads, there are many idle cycles that are there, many idle CPU cycles. And we figured out a way to pack in some of the workloads in those idle cycles and therefore extract more output out of the same compute capacity.
Fantastic. So I think one of the things while we were discussing yesterday, right? I mean, with my limited knowledge, one of the things that came out, I always used to think that Spark always goes with big data, Hadoop, building nodes, but can you tell us a little bit about how you're using Spark to optimize for small data? I mean, not only big data, but for small data also.
And that's a great point. I think Spark was built for a world when people were a little intimidated by this entire big data, and there was a lot of emphasis on finding the right solutions of how to handle the big data. But over the years, what came about is that the so-called big data cases or use cases are perhaps less than 1% of the use cases that most organizations face. Typically, and there is research to back it up, that most of the time the workloads are running on less than, let's say, 100 GB of workloads. Only 1% of your workload would be more than 1 GB. And that is where at some of these times, when the workloads or when the data is not so big, the execution on Spark can be improved, right? Spark comes with its own overhead of JVMs and everything, which slows down the execution. And some of the new solutions that have come out in the market, such as DuckDB, which are picking up, those are purpose-built for optimizing on these kind of use cases. And we've adopted a similar approach. We've looked at how the same approach that, let's say, the likes of DuckDB use can be incorporated into Spark. And that's when we thought about building it through the turbo engine.
Fantastic. Yeah, one of the things that I'm not going to, because this is still, I understand talking to you guys, it's still in your thought process, but it was a fascinating idea when you said that you guys are thinking about how to eliminate pipelines. I don't want you to tell us about this because you're still in the phase, but that's something that we definitely need to talk about sometime in the future. So finally, how is AI impacting your day-to-day development, delivery, implementation, right? Or architecture?
Absolutely, that's a great point because AI is everywhere, and I think for us what we see the use cases of AI in broadly two areas. One is, of course, in accelerating the development of all these jobs. So how quickly, let's say, somebody can write code, validate the code, troubleshoot the code. That is one use case. Or if, let's say, you're writing a complex SQL query, sometimes it becomes difficult for developers to do that. So how quickly you can do that, because that saves very precious developer bandwidth.
Sure.
The second is on the operational side of it. So one part of it is running the code as well, and that's where the operational side of AI becomes very important. Which is where, let's say, if something goes wrong, how do you troubleshoot it?
Right.
Or how do you kind of figure out how to optimize that workload?
Correct.
So what we looked at is that we talked to some of the best engineers in the business, and we looked at their thought process of how they would go about optimizing jobs or troubleshooting errors. And we incorporated all of that into an agent of our own and built it into the product. So let's say if your data team is running certain workloads and they face some issues, instead of spending a lot of time trying to figure that out, they can ask the AI to go and fix it for them.
Correct.
And it gives a fairly detailed answer.
Yep.
So
and that knowledge has been grown from your best engineers. Right?
Absolutely, from the best engineers. So it incorporates all of those principles.
Best practices.
So, absolutely. So what would otherwise happen is that these best engineers would have to come on a call, troubleshoot each and everything, and their bandwidth is also very limited, right?
Absolutely.
So which is where a solution like this comes in.
Absolutely. No, I think one of the most important message that came out of this conference or symposium, right, is optimization, but not necessarily at the expense of human. It is how do we enable our engineers to use their time
much more productively,
efficiently, but come out give the same result, if not better. I think that's something that I'm going to be.
Absolutely, that's the key message.
And I think that's what I got from your company also when we were speaking yesterday. What was fascinating is that you all are thinking through that. So
absolutely.
Thanks a lot, Mayank. We hope to connect again pretty soon.
Sure. Thanks, Saurav.
Thank you very much.
Thank you. Thanks a lot.